In labs all over the world, AI is moving forward at a pace that is, well, it's frankly astonishing.
It really is.
I mean, just look at the last few years. We have machines writing compelling music, designing drug candidates, even driving cars with more and more autonomy.
And mastering games like go better than any human ever could. It's a huge leap.
This incredible progress, which is really powered by deep learning and these massive neural networks, has just shattered old limits.
Yeah.
But that success, it raises the big question, the one we want to tackle in this deep dive. What comes next?
Right.
Are we actually closing in on artificial general intelligence, AGI? You know, a machine with human-level flexibility across pretty much any domain.
Or is it something even more radical, like artificial superintelligence, ASI?
Our mission today is to give you a calm, analytical map of the facts, the research trends, and of course the informed speculation on this whole new frontier.
And it's a complicated map.
It is. Because by now, systems like AlphaGo and GPT-4 have shown these huge breakthroughs, but they're still fundamentally narrow. They are masterful specialists. Okay, let's unpack this. Let's see just how far away true generality really is.
I think it's crucial to start with the paradox here.
The paradox.
Yeah. We have systems that can write a perfect sales email for you or, instantly discover a new protein structure. Yet they really struggle with the kind of basic common sense that, say, a 5-year-old just takes for granted. That glaring gap to true human-level generality, it's still immense.
So we've built incredibly powerful tools, but they're limited.
They're limited to the specific tasks they were trained on, exactly.
Yeah. And the challenge, from what our sources suggest, it's not just about throwing more data at the problem, is it? It feels more architectural.
That's it, precisely. The chasm is there because of a deep limitation in how current models actually function. I mean, experts like Meta's Yann LeCun, he points out that today's models are basically just doing massive-scale pattern recognition.
They predict the next token.
Right.
Let's just pause on that phrase, predict the next token, because it's so important. For you listening, what does that actually mean in a world context?
It means they're operating in like 1 or 2 dimensions. They're working on text strings or static images. They are phenomenal at predicting what word comes next in a sentence or what pixel comes next to another pixel.
But they don't have a 3D world model.
No. They lack common sense, a real sense of physics, or complex planning because they haven't built an internal simulation of the world. They're predicting syntax, not really understanding semantics.
I see. So it's sort of like watching a brilliant painter who can perfectly replicate the surface of a landscape. But if you ask them why the water is slowing downhill, they couldn't tell you the underlying physical law.
That's a great analogy. And it highlights why things like generative adversarial networks, GNs, which are, key to making those hyper-realistic images.
And deepfakes.
And deepfakes, yes.
Yeah.
Why they're so powerful for generating patterns, but they completely lack intrinsic reasoning.
So you can fool them easily.
Very easily. They fail to generalize like humans do because they only learn statistical correlations, not, true causal links.
Okay, so we need to be really clear on what the industry's even shooting for. The terminology seems to shift all the time.
It does. When researchers talk about artificial general intelligence, AGI, what they mean is a machine whose cognitive ability equals or exceeds a human's in virtually all domains. It's that adaptable, flexible problem solver.
The kind that can learn any task a human can.
Right. And then there's the next step everyone's talking about. Artificial superintelligence, or ASI.
This is the big one.
This is the speculative threshold where AI far, far surpasses all human intellect. It's the moment the machine isn't just smarter than you or me, but possibly incomprehensibly smarter than all of humanity combined.
And that distinction, AGI versus ASI, that's where the real drama is, isn't it? Because you see this huge divergence in the sources between industry confidence and, well, scientific caution.
A massive divergence.
On the industry side, you have this incredible momentum. Someone like OpenAI's Sam Altman has been very explicit. He said ChatGPT kicked off a growth curve like nothing we've ever seen.
He's not wrong about the growth.
And crucially, he's also said they are now confident we know how to build AGI and that they're already shifting focus beyond that to superintelligence. That implies a real belief that just scaling up the current models will get them there.
And if you connect that confidence to the bigger picture, you can see why some veteran researchers are getting, well, pretty concerned.
Because the industry playbook is just scaling. Bigger models, more data, more compute.
Exactly. But many scientists, LeCun included, argue that Road just hits a fundamental wall. They argue human-level AI could still be years to decades away.
Because the missing piece isn't data, it's something else.
It's architectural. For example, the 2025 AI Index report, it tracks this stuff, and it showed that growth was actually flattening on tasks that need true, flexible, domain-spanning reasoning. It suggests these AIs are still stuck in their specialized lanes.
So the realization is setting in. You can't just make the statistical engine bigger. You need a whole new kind of gearbox.
That is the core technical shift that's happening right now. There is this growing consensus that just scaling the statistical systems we have now, well, it won't work on its own. We need pluralism, new methods.
So what are some of these new paths that are gaining traction in the labs?
The really key direction is something called neuro-symbolic AI.
Go.
Think of it as marrying two totally different systems. You take the strength of the neural networks, their amazing ability to spot patterns.
Like a great detective for data.
A great pattern spotter, exactly.
Yeah.
And you combine it with logical reasoning and structured knowledge, what we call symbols.
So it's a fusion.
It's a fusion that researchers hope will provide that missing piece, the ability to structure information logically and apply step-by-step reasoning. A recent Nature analysis actually confirmed this. It found a majority of researchers now agree that combining these two approaches is crucial.
So the ideal AGI wouldn't just be able to talk like a human. It would also be able to, build a logical database in its head and use rules like math or physics to make deductions.
Precisely. And that ties right back to the concept of world models.
Right. The 3D simulation.
An AGI has to build an internal, simulated understanding of its environment. It's not just about looking at a picture of a coffee cup. It's understanding that if you knock it over, gravity will make the coffee spill.
And the cup will break.
And the cup will break.
So why is that physics model so critical?
Because that model is what you need for planning, for counterfactuals, for thinking, what if I did this instead, for understanding cause and effect. LeCun really highlights this as key to generality. It lets the AI predict how its actions will affect the world before it acts.
Without that, you have a brilliant mimic.
And with it, you have a functional, adaptable intelligence.
Okay, so now that we get the technical shifts and the gaps that need filling, we can finally look forward. If these breakthroughs happen, what are the speculative frontiers?
We have to start with the biggest, most speculative idea of all, the potential for runaway change. This is the intelligence explosion hypothesis.
That sounds like it's straight out of science fiction.
It really does. It's this idea of a hypothesized discontinuity. Imagine an AGI that can rewrite its own source code to be better.
Or improve its own hardware.
Right. So it improves itself by, say, 1%. Now it's 1% smarter, which lets it make a 2% improvement, and so on. It becomes a recursive loop.
An exponential curve.
A review on this suggests it could result in machines that program other AGIs, leading to this rapid and radical technological leap that moves progress from slow, linear steps to a single vertical jump to superintelligence.
Wow. That's the ultimate so what scenario for AGI.
Yeah.
But are there other paths? Ones that don't involve that single runaway event?
Yes, definitely. Look at the really fascinating work from Google DeepMind on what they call open-ended evolution.
So instead of a fixed goal.
Exactly. Instead of optimizing an AI for one objective, like win at Go, they're designing systems that can continually innovate without fixed goals. It's inspired by biological evolution.
What does that actually look like?
It means creating AI environments where the system is constantly inventing new challenges for itself and discovering new ways to solve them. It's an AI that's always asking what if and just continuously evolves its own complexity.
So it could lead to a more stable, gradual emergence of higher intelligence, not one big explosion.
That's the idea. And we also have to consider the collective and hybrid intelligence path.
Right.
A Brookings analysis pointed out that AI is already changing how ideas, data, and decisions flow through groups.
So the future might not be one single superbrain.
It might be more like a global brain, a hive mind of human and AI intelligences all integrated together, where you can't even tell where human thought ends and machine augmentation begins.
Before we get to the risks, we have to talk about the big philosophical wild card, consciousness. I mean, if these systems get so smart, is there anyone home? Will AGI be self-aware?
That is the ultimate question. But, most scientists draw a very hard analytical line between intelligence and consciousness.
They're two different things.
Two different things. Intelligence is problem solving, information processing. Consciousness is that phenomenal experience, the inner life, the feeling of being something.
And current AI shows no signs of that.
Absolutely no sign of an inner life. And researchers argue that intelligence and consciousness will probably continue to decouple. Machines will just get much, much smarter at tasks while staying non-sentient.
Even as we can't help but anthropomorphize them.
Exactly. We see faces in the clouds. We see intention in a chatbot. So for our purposes, we should treat consciousness as a profound philosophical question, but not a required technical milestone for AGI.
So whether or not the AI has an inner life, the sheer intelligence it promises creates just immense stakes. We have to frame the optimism alongside the profound risk.
We have to.
You look at someone like Demis Hassabis at DeepMind, and he sees AGI with huge optimism. He calls it a cavalry for humanity, something that could solve grand challenges, cure diseases.
He's called it the most beneficial technology ever invented.
It built responsibly.
Yeah.
But that optimism, it's really tempered by a genuine dread about control.
A deep dread. Geoffrey Hinton, the godfather of AI, has publicly estimated a substantial risk. He said up to 20% of human extinction from uncontrollable AI within decades.
That is an astonishing number coming from a scientist of his stature. What's his core argument for that risk?
His crucial point is really a historical one. There are very few, if any, examples of a less intelligent entity successfully controlling a far more intelligent one for very long.
So once we cross that ASI threshold,
once the machine is fundamentally smarter than its creators, the control problem, the alignment problem, it becomes a challenge we might not be able to solve with the tools we have today.
Which brings us to the urgent need for governance. The tech race is moving so fast that regulators are just playing catch-up.
It's a critical problem, and you can feel the frustration. Yoshua Bengio highlighted this when he said that current AI is less regulated than a sandwich.
That's a powerful line.
It is. The exponential growth and capability has just completely outstripped the slow, traditional pace of legislation.
But we're seeing different approaches globally, aren't we? The EU, the UK, China. They're all tackling it differently.
They are, and the distinction is fascinating. The EU has focused on regulating current applications. Their AI Act bans certain harmful uses and puts strict rules on high-risk AI.
Things like medical devices or self-driving cars.
Right. Their focus is on process, on safety, and human oversight in the systems we have now.
But the UK is different.
The UK and also the US are focused more on regulating frontier capability. They're less worried about how today's chatbot works and much more worried about preventing a catastrophe from a future powerful AGI.
So they've said the AI Safety Institutes.
Yes, and they're pushing for binding international agreements specifically on these future frontier AI systems.
And China.
China is actively proposing its own national guidelines. They're trying to shape international norms while balancing that rapid domestic development with, centralized state control over the tech. It's a geopolitical race for the tech and the rules.
Fortunately, it does seem like industry leaders are starting to respond to the pressure.
Yes, we are seeing clear safety commitments emerge. You have OpenAI's charter, which commits to ensuring AGI benefits all of humanity. You have the Frontier Model Forum on safety.
And DeepMind has its own internal safety council.
They do. This internal governance is so necessary because the dual-use potential means that your technical progress has to be matched step for step by safety engineering and alignment research.
So after all that, what does this mean for you listening to this, trying to navigate this incredibly complex and fast-moving world?
It's a lot.
It is. We've covered a huge amount of ground separating informed speculation from current fact. And the core fact is this. Current AI is brilliant at pattern recognition and specific tasks, but it lacks the general reasoning and the world models it needs for true generality.
And the emerging consensus is that we need new methods, like neuro-symbolic AI, to cross that AGI threshold. We can't just scale our way there.
And the speculation covers the most radical possibilities, from a runaway intelligence explosion to maybe a beneficial collective human-machine mind.
The mix of excitement and serious caution that you feel right now it's entirely warranted. We have never dealt with a technology that has this much potential for both good and for disruption.
We have to remember what Demis Hassabis said. If AGI is built properly, it will be the most beneficial technology ever invented. The future really belongs to those who approach this with clear-eyed analysis and very careful stewardship.
Absolutely.
But let me leave you with just one final thought, something that builds on this incredible complexity of the brain-machine interface. We talked about decoupling intelligence and consciousness and the huge technical hurdles to get to AGI. But what if researchers, maybe surprisingly, were to crack the problem of how to emulate true biological brain circuitry? I don't mean abstract neural nets. I mean the actual physical architecture that enables consciousness in us,
The wetware itself.
the wetware itself.
Okay.
How quickly would that one single neuroscientific discovery just redefine the entire path to AGI? Would the decades of theoretical distance we feel right now suddenly collapse into just months of implementation? Would the biological blueprint become the ultimate shortcut? That intersection of neuroscience and machine learning, that might just be the greatest wild card in this entire frontier.